Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hazwan Hasnol Habibe bin Hayat from Bachelor of Science Honours in Biology. Today, I will present to you about my thesis titled The Effect of Climate Change on Rice Production in Malaysia. My thesis is supervised by Sir Muhammad Saiful Bakar bin Muhammad Sahal. Rice is the most significant crop in Malaysia's food subsector for two reasons. The crop is the main source of income and food for rice farmers, especially small-scale farmers and people who work in agriculture without land. Agriculture, fishery and forestry make for approximately 8% of Malaysia's gross domestic product and employ approximately 10% of the country's labour force. Climate change's effect on water supplies and crop productivity are delicate concerns that the majority of agricultural countries are already grappling with and will have to address on a global scale. According to Wander et al., climate change has become a major global issue in recent years, especially for poorer countries where it has big effects on the agricultural sector, among other things. In 2017, crop and livestock production losses caused by floods made up 37% of all losses, while 90% of losses in developing nations were caused by drought. The importance of agriculture sector to the growth of these countries and its role as the backbone of the economy in terms of self-sufficiency, reducing poverty and giving many people jobs makes these losses even more important. The goal of this study is to evaluate the effects of climate change on agriculture with a focus on rice production in Malaysia. It will also try to come up with and suggest possible ways to counteract those effects in the hope that these ideas can help with growing rice and keeping Malaysia's rice production sustainable in the face of climate change. The overall goal of this research is to assess the effects of climate change on rice production in Malaysia. The specific goals of this study are to determine the effects of climate change on Malaysian rice production and develop countermeasures to the effects of the climate change. According to Dong et al., rice is the main crop that is irrigated in Malaysia. It is grown twice a year on 322,000 hectares of land, mostly in 8 large-scale irrigation schemes. The country makes about 80% of the rice it needs, which was about 1,820,000 metric tons in 2018. Verhey stated that the environment, soil quality, living conditions, and cultural practices all affect how and how much rice grows. Rainfall and water, temperature, photoperiod, soil radiation, and in rare cases, tropical storms are also environmental factors. The 8 main places where rice is grown are Muda Agricultural Development Authority, Integrated Agricultural Development Area Pulau Pinang, Kerian, Seberang Perka, Barat Laut Selangor, Kemubu Agricultural Development Authority, Kemasin and Ketara. They are about 383,990 hectares in size and produce more than 70% of the country's rice. Even at this high level of production, Malaysia only makes about 80% of what it needs to be self-sufficient. The rest must be brought in from other countries. About 1.51 million metric tons of rice were grown in Malaysia in 2020. According to Kasim et al., on average, adults in Malaysia ate 2.5 plates of white rice every day. Raja Moorthy et al. Stated that Dasar Agromakanan Negara was created by the Ministry of Agriculture and Agro-based Industry to make sure that there is enough food and to reform the agro-based industry to make it more competitive, sustainable and profitable for entrepreneurs. According to Wong et al., Malaysia is located between the tropics and the equator, which latitude is between 1 degree north to 7 degree north and 99 degree east and to 105 degree east. The weather is called equatorial, tropical rainforest or wet humid tropical, and the daily temperature are pretty stable. The average temperature changes between 26 degrees Celsius to 28 degrees Celsius over the course of 1 year. Because changes in temperature are so small, changes in rainfall play a big role in figuring out how the season changes. The monsoon winds that blow in peninsular Malaysia are different at times of the year and are directly linked to these changes in rain. This effect on monsoons can be seen in the way temperatures changes with the season, since some months are much wetter than the others. According to Allen, climate change is a broad term that includes both global warming and how it changes the weather pattern on Earth. Climate change has happened before, but the changes occurring now are much faster and are not caused by the natural processes. Ritchie has stated that the burning of fossil fuels to make energy is responsible for most of these emissions. Agriculture, making steel, making cement, and cutting down forests are also sources of emission. Greenhouse gases in the air stop heat from escaping. Forcing climate changes are gases that stay in the atmosphere for a long time and don't react to changes temperature either physically or chemically. Feedbacks are gases like water vapor that change physically or chemically when the temperature changes. Based on some material and linked study of data from weather observations, the yearly mean of the day's lowest temperature is going up more than the day's highest temperature. Peninsular and East Malaysia often have less rain during El Nino years. East Malaysia weather is more affected by El Nino than Peninsular Malaysia's. Precis predicted that Peninsular Malaysia, Sabah and Sarawak would have warmer average daily surface temperatures in the 21st century than they did in the 20th centuries. Temperature and precipitation are some of the factors of climate change. According to the World Bank Group, temperatures rose 0.14 degrees Celsius to 0.25 degrees Celsius every decade from 1970 to 2013. Depending on world emission, they might rise from 0.8 degrees Celsius to 3.1111 degrees Celsius by 2090. Temperature rise should be minimally seasonal. More frequent and violent heat waves are expected. A 3-day period with above average temperatures have 2% chance of happening. This rises to 93% in high emission scenarios, indicating temperature rise. Such high temperatures may worsen in metropolitan heat islands like Kuala Lumpur, which is 4 to 6 degrees Celsius hotter than its neighbors. In high emission scenarios, heat-related death among the elderly might rise to 45 per 100,000 person. Malaysia is vulnerable to changes in precipitation patterns due to its reliance on surface water, but forecasts expect no significant changes, and Kelantan and Pahang may receive additional water according to the World Bank Group. East Malaysia will receive more rain than the peninsula. The extent of the rise varies greatly between predictions and emission scenarios. Under high emission scenarios, the rise will be approximately 12% greater than the current 2,732 millimeters. Flooding is a common and developing hazard as a result of heavy rains. Floods might kill 200,000 people each year between 2070 and 2100 under high emission scenarios. According to World Health Organization, rainfall could be 32% more severe in the 2090s. In conclusion, climate change is detrimental to Malaysia's agriculture, particularly rice production, which is the country's most important crop. Several research indicate that the climate change would impact rice production in Malaysia. The great majority of climate change impacts on rice production are caused by changes in precipitation and temperature, which cause flooding, water scarcity, and an increase in insect, pest, disease, and weeds. Complex climatic changes and their effects, scarcity of arable farmland, social and economic transformation, the influx of low-price rice from neighboring country, insufficient property assets, and reliance on smallholder agriculture are anticipated to impede the future development of the rice sector in Malaysia. Fortunately, climate-smart farming choices are available. These methods have the potential to increase productivity, improve climate resilience, and reduce greenhouse gas emissions. Some of these methods are already in use, with encouraging results that point to their wider applicability. Adopting climate-wise agriculture techniques such as alternate wetting and drying water management in conjunction with successful farming practices has shown the ability to significantly cut methane and nitrous oxide emissions. These solutions include a package of irrigation water supply improvement, land leveling, and the use of improved seeds, improved tillage practices, soil testing combined with enhanced fertilizer administration, and farmer training, which is typically helped by digital technology. Rice waste such as straw and rice husks can be recycled as animal feeds, growing beds for other crops such as mushroom, bioenergy inputs, and leftovers as organic fertilizers.